Hey everyone, it's Mr. Canfield. Today we're doing Algebra 1, Chapter 2-2 or 2.2, topic 2-2, 2-2, 2-2, 2-2, 3? No, 2. Okay, so we have a warm-up question here, or I guess some people call it a do now. Do now. Do the two equations represent the same line? Okay. So Paul over here, he takes his y equals mx plus b. Looks like he puts a 2 in for a y. Okay, so I could, go back in time and be like, he's got a 2 for the y. Looks like he puts a -5 for the m. Okay. Looks like x is 4. Okay, so I have this information. Let's see what he does next. Okay, so he does -5 and 4, so he multiplies those, he gets -20. Wait, how does he get here? Well, it looks like b is by itself. Oh, maybe he adds the 20 to both sides. 20 plus 2 is 22. Okay, so he finds out that b is 22, so he writes y equals -5x plus 22. Okay. Seth looks like he takes the slope formula. Looks like he leaves y and x just as y and x. Then looks like he puts a 2 in where y was. Wait, see how y was there and now there's a 2 there? That means that this line passes through the point 2 for y. It says minus, but remember that the formula says minus. So same thing on the bottom. If it said plus, that would be a negative for them, but it's just a regular +4. Oh, so it goes through the same point. Interesting. Wait, and m says he replaces m with -5. So are two lines the same if they have the same slope? Remember, m was slope. Do they have the same slope, go through the same point? Are they the same line? Spoiler alert. Yes, they are the same line. So, okay. But how does he get from here to here? Well, he does something a little fishy. See how it says y minus 2 fraction bar x minus 4? Remember, this fraction bar here means divide. So if you want, you can get rid of divide by using multiply. So if we multiply both sides by x minus 4, that's why he got that. This is very weird looking. But it's true. So I'm acting bewildered. This is a special formula, a special format. So we have y equals mx plus b. And this was called slope intercept form, right? This is our form where m was slope and b was our y-intercept. This is very close to the way that we're going to write something called point slope form. So we call this one point slope form. And this gets into the super creative ways that mathematicians name things. This was called slope intercept form because it had the slope and the intercept. So like the only thing it's missing y-intercept. If only this was called like the slopey intercept or something with a little y in there, but this one's called point slope form. Guess why? If we know a point and we know a slope, we're able to write it in this form. And we'll talk about how that works today. It's actually very easy and goes very, very quickly. And so because of that, a lot of people get hung up on it. It winds up being easier than we feel like it should be, and we get confused, we get turned around. So I am here to help and to hopefully explain this well. All right, let's see. So if we know points on a line, the first thing we need to do is find slope. And you can either use m equals y2 minus y1 over x2 minus x1, or graph points and count the rise over earn. Canfield, rise over run, oh dear. If we know slope, remember that's m. And then we can just go and we can use point slope form. So we'll talk more about that in our next problem. So example 2, a line with a slope of 1/2. Slope of 1/2, so 1/2 is equal to m, okay. Passes through the point 3, -2. What form can you use to write the equation of the line? What is the equation in that form? So I have the slope and a point. Well, hey, I can use point slope form. So this is how point slope form works. Y stays there. X stays there. Guess where the slope goes? In the m spot. What's our slope? 1/2. 3, -2. Remember, points go in alphabetical order, so this is x, y. So that means that 3 is our x. Notice in the formula, it says x minus x1 and y minus y1. It's always going to be minus these numbers. And that's a little bit confusing for you. It's always going to come in and it's going to look like the opposite of what it actually is. So it's not going to say x plus 3 here. It's going to say x minus 3. And it's not going to say y minus 2 because it's already minus. It's going to say y plus 2. This, although it might not feel good, this is actually graphable, and this is the equation of this line, and we're good. We can walk away. All right, our next example, a little bit of a printer problem, isn't there? Okay. So let's see. Let me write these numbers down. Okay, so we're trying to find the equation of the line that goes through these 2 points. I'm going to do this a couple of different ways. So let's start out and let's do this the old-fashioned way. Say, I don't feel like doing formulas. I don't feel like figuring any of that out. I'm just going to count. Literally just going to count. A lot of math teachers have a problem with us doing this because it kind of cheats the system a little bit. Let's see. The point, -4, 1, remember it's x, this is y, this is x, this is y. Okay. 2, 3, 4, 1. So I went, x was -4, y was 1. Now x is 2, and y is 3. So if I want to find the slope between those 2 points, I can just count the rise over run. 1, 2, 1, 2, 3, 4, 5, 6. Rise 2, run 6. There's our m. Now, I know this is a fraction that simplifies, so the way that I know that is, as soon as I did it, I saw 2 and 6 are both divisible by the same number. I can divide them both by 2. Divide 2 by 2, divide 6 by 2. If you divide the top and bottom by the same number, you get the reduced fraction of 1/3. But you can also use your calculator. So I already know, if I'm using what's called point slope form, now that I know my slope, I can say y, there's going to be something there, m is 1/3, x, and there's going to be something there. And all I got to do, I can take either one of these two. It doesn't matter. It really doesn't matter. I'll take the 2, 3. Well, 3 was y, so y minus 3, x minus 2. This is an equation of this line. Here's another one. What I do is I use this point instead. So we'll take the y minus 1, x, oh, not minus 4. It's minus -4, which is plus 4. So there's my other equation of the line. So here are 2 different equations of this line. There's still another way I could do this. I don't recommend it, but it will work. I can say y equals mx plus b, and I know that m is 1/3, y equals 1/3 x plus b, right? And I can solve this. I can plug in the 2 for x, the 3 for y. I can get 3 is equal to, 1/3 times 2, that's 2/3 plus b. And then we're going to subtract the 2/3 from both sides. Hopefully I'm convincing you that this is not as nice of a method right now. So what is that, 9/3 by 2/3, that's 7/3. So I could get y is equal to 2/3 x. Nope, 1/3, m was 1/3. 1/3 x plus 7/3. Ew. Ew. We have point slope form. If we know the slope and we know a point, done. You can pick either one. They are both true. They both work. So, all right, we got another example. This one's not numbered, so it's example 2 again. Shouldn't have made myself laugh that much. It wasn't funny. And if it was funny, it wasn't funny. It was like, ugh. All right, so this is our next example. So again, I can actually jump to the end if I want. X, y, x, y. I could be like y minus my y value, or y plus 1. I don't know m yet, but I do know it's x minus my x value. Or I could say y minus my y value, and then x minus my x value. I just need to find out what m is and drop it in. And then either one of these would be an acceptable answer. So all I have to do is find m. So I'm not going to draw this one and plot the points, even though, honestly, it might be a little bit easier. I can just go drop it on there. So the reason why I would want to use the slope formula is slope formula makes it so that if I'm having a hard time counting things out, I'm going to get the right numbers. Or what if instead of being 2, -1, and -3, 3, excuse me, it was like 86,452, comma, -121.5, and then it was like 2, and then 40 billion. Oops, comma in the wrong spot. Going and counting this out isn't going to work. Instead, we can use our formula to arrive at the numbers that we need. So that's the real reason some math teachers get really bent out of shape when you do the counting method that we did a minute ago. This counting method is great, but so is the formula. So remember, we're calling these our 1s and we're calling these our 2s. So I can say y2 minus y1, so 3 minus -1. Instead of writing minus -1, I could write 3 plus 1. Anytime you have minus a negative, that's what it really means. Then we have -3 on, nope, yeah, x2, right? x2 minus x1. Okay. So on the top, we have 3 plus 1, which is 4, and on the bottom, we have -3 minus 2. So -3, and then lose 2 from that, get more negative, so -5. So our slope is -4/5, and we're done. Literally it. So if this is making sense to you, I'm super happy. If you have any questions, I would love to help you out. Remember, you just send me an email. We'll take care of it. But if you aren't letting me know that you need help, I can't know that you need help. All right, our next one says, what is the giraffe of y minus 3 is equal to -2/3 x plus, it's a big mess. Well, let's do what we did earlier. What's our slope here? Remember, according to our formula, our slope is that the one that hangs out there. Okay, so -2/3. Let's find our point. It says x plus 1. So what would the number be to make it show up as a +1? It'd be a -1. This says y minus 3. What would this number be to make it say y minus 3? It'd be a regular 3. So if you work backwards from the equation, you can actually find m, you can find the slope if it's in point slope form. Now all I gotta do, well, let's see, let's go to this point, negative 1 comma 3. That's x, that's y, right? So x is negative 1, y is 3. So there's my point. And then it says slope is negative 2/3. So I'll just go a slope of negative 2/3 here. I'll go down to 1, 2, 3 over. Oh, I can even do it again. Down to 1, 2, 3 over. Or I could reverse it, go up to back 1, 2, 3. And remember, our solution, this line here, this is saying any point on this line, if I plug that x and that y of that point, so even this like ugly decimal point here, double decimals here, if I plug them in, that's gonna make a true statement. So negative 1 comma 3 will make a true statement, so will 2 comma 1, so will 5 comma negative 1, so will wait, 5 comma negative 1? Sorry, I got distracted. Okay, so so will any of these decimal points? Okay. So then it asks me to sketch the graph of this guy. Well, okay, well let's do the same thing. What's our slope? Right? What's our y-intercept? Not y-intercept, silly me. Our y is, it says plus 2, remember, so that's gonna be negative 2. X minus 3, so it's gonna be regular 3. So 3 comma negative 2. So all I'm gonna do is I'm gonna go to 3 comma negative 2. Then rise 1, run 2. Or like, you know, go down 1, go back 2. So when we're graphing these by hand and we're drawing our coordinate planes by hand, it gets pretty dicey. I don't recommend doing this. If you have access to graph paper, I highly recommend it. You can even print out graph paper. Okay, so got a few more problems to get through. I know we're only halfway through the pages for the notes, but I feel like the rest of this is gonna fly by. All right. An event facility has a banquet hall that can hold up to 250 people. The price for a party includes the cost of the room rental plus the cost of a meal for each guest. Marissa is planning an event for 75 people. She has budgeted $1,200 for the property. Will it be enough? I'm not gonna lie, my brain did not absorb hardly any of this. I learned that Marissa makes food for people. That's as much as I picked up. An event can hold up to 250 people. She has an event for 75 people. So I don't even care about this 250. She has budgeted $1,200 for the party. Okay, so I'm really trying to figure out, is 75 people, is $1,200 enough for 75 people? Okay. So let's see, total cost, number of guests, 75, that's exactly halfway between 50 and 100, right? So, all right. I'm gonna solve this the way that they want me to solve it, but then I'm gonna solve this the way I would actually solve it. So the way that they want us to solve this is they want us to find the point slope version of this equation, because we have the point 50 comma 725, and we have the point 100 comma 1325. With these, I can find the slope using the slope formula, right? I can do 1325 minus 725 over 100 minus 50. If I do that, I get, that should be 600, right? 1325 minus 725, yep, 600. 100 minus 50 is 50. So 60 divided by 5 is 12, okay. So my cost is $12 per guest. That's how much it rises per one. Rise 12 per one run. And then what they want me to do is they want me to say, well, okay, I can use one of these 2 points then. I can say y minus 725 is equal to 12 times x minus 50. And then I can plug in 75 for x. And then I can solve for y and see if, I guess I could plug in 1200 for y, right? And see if this winds up working. What I'm gonna do is a little bit different. Instead of doing all that, I wanna find out how much it's actually gonna cost at 75 people, which is exactly halfway between the two. So if it's halfway between the two and it's rising at a constant rate, which I think we're gonna assume for this question, I know 1325 minus 725 is 600. So if I wanna find out, oh wait, no, I don't even need that. I can just like average those two numbers, right? 1325 plus 725 divided by 2. It's gonna cost 1025 to do halfway between those two numbers, right? So it's only gonna cost 1025, so that means, boom, we got enough money. So they probably want us to do, right, an equation for the line, but when a word problem is contrived like this, I don't have a problem sidestepping it and doing common sense. All right, so next time we're gonna focus on how to do a problem like number 4. So we're gonna come back to this. We aren't gonna see anything like this on the homework tonight or anything like that. That's gonna be for next video. Error analysis. Denzel Washington identified 3, 2 as a point on the line. What is the error Denzel made? Okay. Well, let's see. Well, what's our slope here? Our slope's 2/3. Cool. Not part of the question. Just figured I'd talk about it. So let's look at the 2. I see the 2 first. It says y minus 2. Is that right? Yeah, remember, it's always the opposite of, so like, if it's regular 2, we write minus 2. If it's regular 3, we write minus 3. Oh, but we have plus 3 here. So he saw the plus 3, and he wrote plus 3. What he should have done is written minus 3. So what was the error Denzel made? He did not take the opposite for both x and y. So write the equation of the line and point slope form that passes through the given point. Well, so literally, m is -3. Where does that go? Where m is. X minus x. X, y, right? X minus 1, y minus 5. Done. It's always the opposite. That's it. So slope stays the same, the x and y switch. That's how point slope form works. Pretty straightforward. Let's do a few more. We are almost done. Point slope form. There's our point, there's our slope. So y, well, which one of those is y? The 3. Y minus 3. M is 2. X, not minus 4 because it's already minus. X plus 4. Then, oh, both of these I don't have the slope yet. So again, you can go to the graph or you can use the slope equation. Sorry, the slope formula. So 6 minus 2. Y2 minus y1. 1 minus 4 is the bottom. So I get 4 on the top, I get -3 on the bottom. And then I get to pick which one I want, right? So I can say y minus 2 is equal to negative 4/3 times x minus 4. Or I could say y minus 6 is equal to negative 4/3 times x minus 1. One thing to be careful of, whichever point you start with, end with that point too. So if I use the 4 for x, I can't use the 6 for y. I need to use the one from the same point. So same thing with this one, negative 4 minus 8 over 7 minus negative 2. Well, negative 4 minus 8 is negative 12. 7 minus negative 2 is 9. So negative 12 ninths. I wouldn't mark you wrong for not simplifying it. Simplify it. So I can divide them both by 3 and get negative 4/3. You know, our calculator simplifies these things for us. We're going to say y minus 8 is equal to negative 4/3 times x plus 2. Or I could say y plus 4 is equal to negative 4/3 times x minus 7. I got thrown off for a second. Make sure you're going back and double checking those things. And then we're going to come back and we're going to do one like number 9 next time. And just the final one's these two graphs. Oh, let's see, I have the point 2 comma negative 1, so all I got to do then is y plus 1 is equal to, oh, I don't know slope, x minus 2. But I could count slope. Here's one lattice point. Any other lattice points? There's a lattice point. Looks like I go down 2 over 1. So I write negative 2 over 1 or just negative 2. There's another lattice point for this one. 1, 2, 1, 2, 3. 2 over 3 is my slope for that one. So points 3, 1. So y minus 1 is equal to 2/3 times x minus 3. Okay. Ladies and gentlemen, babies and bebblemen, ladies and gentlemen, I hope this was helpful. Some people have complained that my videos are long. It's like, well, yeah, because it's replacing a teacher talking for an hour. So, of course it's long. There's a lot of material. But yeah, I hope this works for you. If it did work for you, let's have a secret code. If it was helpful for you, at some point in the next day or two, you should say something. Something silly. What would something silly be? Mr. Canfield, Mermaid Man and Barnacle Boy are my favorite. How about that? If it was helpful, feel free to say that to me. If it was unhelpful and you got this far, how about Mr. Canfield, I don't like SpongeBob. How about that? Yeah. So Mermaid Man and Barnacle Boy are my favorite. That's the this was good. Mr. Canfield, I don't like SpongeBob. That's the this was not good. But if it wasn't good, please tell me what I can do better to make this work for you. And again, shorter videos, I can't do that because I already go really fast in these videos. You can always speed up the video or skip through the video or do whatever you need to do, but you got to learn the material. And you're either going to learn it in person, or you're going to learn it at home, or you're going to learn it in summer school, or you're going to learn it as a freshman again next year. So it's all up to you how you're going to learn this. As always, I want to help. Let me know how I can help. Bye.